Hi everybody, and welcome to our second episode of our Intelligent Automation series. I'm super happy to welcome you back, and I hope you enjoyed our previous episode. As you might remember, in our first episode we talked about different situations that you might be facing in your organization and where intelligent automation could be one of the potential solutions to solve those situations. And we ended up with talking about intelligent automation and the four dimensions of intelligent automation. And I just want to pick up on where we left there and run you through, just as a quick reminder, onto the four different dimensions we had, and then dig a bit deeper into those four dimensions with really concrete examples of projects we did at our clients. So as a reminder for those that did the first episode, they saw the first episode, intelligent automation is really something you can compare with a human worker and the four main tasks of a human worker, and will help to actually automate those tasks. Now, a first dimension of a human worker is the execution part. So you can actually compare this with our hands. So with our hands we type, we use the keyboard, we type text, we copy paste, and we also use the mouse where we click on a certain button or we click on another application, on the tab in an application to move that part. And that's exactly what the execution part of intelligent automation can do. Once you have that in place, actually, you can start plugging in a bit more intelligent components to it. And the first component is actually language. As a human worker, we continuously use language to communicate, being it in a written form or in a spoken form. We use language. We have a technology what we call natural language processing, NLP, that is really capable now these days of understanding written and spoken language and interpreting them and taking actions based upon them. A third dimension that we can relate to as a human worker is vision, of course. With our eyes, we can see images, videos, and also digital documents, of course, which we can analyze and get information from that, and again take certain necessary actions based upon that. And that's exactly what computer vision can also do. It can analyze digital documents or videos or images and take actions based on that. And then a fourth component, as a human worker, we also try to, of course, think and learn most of the time, at least. And that's where machine learning kicks in. So as a human worker, you always try to refer to past situations, maybe what you've learned there and what the outcome was. Well, the same goes for machine learning. It will think about, or if you feed it with past situations and outcomes, it will try to compare a new situation with past situations and define and calculate the probability of the outcome of this new situation. So these are actually four components, and I actually want to dig a bit deeper into each component with some concrete examples as well. So let's start with the first one, execution. In execution, there is actually we talk about low code. It's really on the rise now to develop low code applications. But I think RPA has been around for most of the time. It's really the technology that is most mature, I would say, in this spectrum. So let's have a look at that, at RPA, Robotic Process Automation. So robotic process automation, unfortunately, maybe it's not a physical robot that's going to sit next to you and bring you some coffee or anything. We're really talking about software here that automates repetitive, time-consuming business processes, right? So you can actually compare it with what you're doing. So wherever you type text, wherever you click, wherever you copy paste, that can also be taken up by the robot. Now you might say, hey, wait, automating processes, I've seen that 15 years ago in Excel where you can do a macro. Indeed, and lately there's also been workflows that you can build up in SAP or Oracle, for instance. Absolutely true. But where robotic process automation really has its value is if you need to automate processes that are cross-application. So maybe starting from an email, extracting information from an email, putting that into an Excel file, doing calculations there, putting that information into your CRM system, and ending up with sending again an email to somebody saying something has been done or to give him an update or anything. That's really working across different applications, and that's where the value of RPA really kicks in. And RPA is not software that is designed for a specific task in finance or in HR. No, it actually is a process, an automated process that you build from scratch, and that can work with, I would say, 99.9% of all applications that we have running in your organization. So it's really a powerful tool that you can deploy in any department that you have. And of course, what is powerful is, of course, that it operates as a back office center, and that goes on 24/7. Unlike humans, it doesn't need sleep. It can work day and night, and it goes, of course, without saying that it does what you tell them to do. So it doesn't make mistakes like humans do. No copy paste mistakes, no typos. It just does what you ask them to do. And just to make this a bit more concrete, I wanted to take you along on an example of a project we did with a customer of ours that is a parking facilitator, and that actually needed to create over 1,000 invoices each month for its B2B customers. Yeah. So as you might know, organizations have their building close to a parking facility, a parking lot. And what they then do for their employees is they offer them subscriptions where they can park their car in every day, but also to guests that come and visit. You might have experienced it yourself. You get a ticket to get out of the parking lot when you visit an organization. Now, what did the parking facilitator had to do? Well, every month, of course, it had to log in to the application that was managing a parking lot and download a CSV file with all the people going in and out of those organizations here that had a subscription or that gave visitor tickets. Now, that didn't take long. It was 5 minutes per parking lot. But what was the problem? Well, they had over 100 parking lots in a specific country. So it took more than 500 minutes, which is roughly a day of work, per month to download all those files. Now, obviously, yeah, a day of work is not that much, but also it was very boring and administrative work that nobody really liked doing, of course. But that was not it. Once they had the file with all the transactions, with all the people driving in and out, they had to create invoices to all of their customers. And that only took, again, 5 minutes per invoice, but now it was over 1,000 customers for which they had to create an invoice. So that took more than 5,000 minutes per month, which is quite a lot. So, I mean, a lot of people were busy with this, and they wanted to really automate this. So what did we do? We actually developed 2 robots. One that could help extract the files with all the people driving in and out from the parking lots, and we developed a second robot that actually started from those files and created those invoices in an automatic way. And I also have a small video of that robot in action, and we're going to look at the last one here, the second robot that starts from those files and is creating invoices. Start the movie here. So you will see that for the demo, we're going to use just 2 files, not 100 files. And you see that those files are here in the folder to be processed. Well, we have 2 CSV files in there, and we're just going to have a look at them, how they are built up. So you see here all the people driving in and out of these parking lots, and they're sorted per customer actually of that parking facility. So that's how the files look like. They're now in the to be processed folder, and later on the robot will pick them up, create invoices, and will put them in the processed folder later. And they will create invoices in Navision here. Voila, so that was the example. Now we're going to start the robot, and we're going to not touch our mouse anymore, and you will see that the robot is taking over. First of all, he's logging in himself in Navision, so he has his own password and username to log in to Navision. And then in the background, he's reading those 2 Excel files and extracting the information from it. And so you see here, the first invoice is already created, but from those Excel files, it goes and looks into the file and look up the customer name, fill it in here, fill in invoice layout code, posting description, and fill out all the transactions, so it can create that invoice in an automatic way. You see, it's pretty fast, the robot, and it just goes on and on like that. It runs through all of those Excel files and creates those invoices for that customer, for the customers. Voila, and now they're in there. So that really goes in a fully automatic way and saves obviously a lot of time for the people that needed to do it otherwise manually. So you can see that RPA here really is a key enabler for operational excellence, right? You are going to get a high return on investment because you can cut your operational cost by 25 to 50%. Now, to tackle maybe a burning question like, will not a lot of people fear for their jobs? Well, I have never seen it actually that people are getting fired because of implementing robots. It's usually that people are overworked, have a lot of work to do, and the robots are assisting them to take away the more boring administrative tasks and to help them focus on their value add. And usually when we look at that, we always try to see a return on investment of roughly 1 to 1.25 years. And so the effort you invest to automate a certain process and the time you free up should actually be repaid within 1 year to 1.25 years. Employee and client satisfaction is an important second dimension. Obviously, employees are super happy when you can take away that boring administrative work. Think about creating 1,000 invoices each month manually. That's really something you don't want to do. So employees are happy that it's automated, but also clients are happy. On two dimensions, employees can spend more time with clients when you automate processes of your employees, but also if you automate client processes that are in direct contact with clients, well, things can maybe go faster, they're better served, and so on. So there's really huge improvement in satisfaction. Scalability is a third component. Once you develop a process, once you have that, you can actually scale that up or down the way you want to. For instance, for those invoices, there might be now 1,000 per month. Maybe if it becomes really busy in the next couple of years and they expand, it can be 2,000. Well, no problem. You let the robot run a bit longer, or if you want to keep the same speed, well, you just copy paste that process into a second robot, so to say, and then they work in parallel at the same speed as before. So you can really easily scale that up and down. Non-intrusive in nature, and that's where actually the power lies, because compared to application development, RPA is really a layer on top of your current applications that works with the user interface just like you and me would do when working on an application. So it sits on top of that, and that's what allows it to go really fast to develop a new process, to automate a new process. And then of course the last one, accuracy and compliancy. A robot will do what you ask them to do. They will not do copy-paste mistakes or typos like humans do. They do what you ask to do. Okay, but I would say enough about robots and the execution dimension. Let's take a look at the following dimension, the first of three more intelligent dimensions, let's say, and that's language. And when we talk about language, we often refer to NLP, natural language processing, as the technology. And that technology actually allows a computer to interpret and to understand language, being in a written format or in a spoken format. A common example here is intelligent chatbots, and I'll refer to that in just the next slide where I have an example of those. But I'm really talking about intelligent chatbots, not the chatbots that we used to know from back in the day, where you typed a sentence and the reply you would get was, "I don't understand you," or "Could you rephrase it differently?" No, chatbots today, equipped with NLP technology, really start making sense of just plain written communications and can really give you an answer that makes sense. And they also learn. When they give you an answer and you say, "No, this is not the right thing, I meant that or that," they learn from that, and going forward you might be able to ask the same question and get a different response that is more tailored, more applicable to really the core of your question. But also sentiment analysis is a nice example. A lot of companies use NLP to scan social media networks and to detect the sentiment, what is going on about their organization. Are people positive and putting happy posts on social media, or are they rather negative and expressing that as well on social media? And that in that way, an organization can know when to intervene or when they need to do something. But let's now take a look at the example of the intelligent chatbots. And actually this example is quite fun for me, because it's not about a chatbot that is directed, that is somewhere on a website for clients to interact with and to ask a bit of stupid questions. It's really an implementation internally in an organization for HR purposes. So what was the situation? Actually, that organization had 2 HR persons working in the HR office, and they were supporting about 250 blue-collar workers. And now these workers had actually continuous questions on sick leave and on forms they need to fill in, on insurance and so on and so on. And they always came by into that office of the HR people and asked those questions all of the time. So they were continuously busy with those questions, the people, and not being able to do their core tasks. So what did we do? We actually put in between an intelligent chatbot where the blue-collar workers could ask their question too, and that actually guided them in roughly 90% of the cases to the right place on intranet or SharePoint where they could find the information or the form that they had to fill in, and so on and so on. Leaving room for really those 10% of all those questions that the people really needed to talk to the person to understand, maybe the personal situation behind it, and so on and so on. So that really freed up time to talk to the people more and more and in depth, as well as to do their core other tasks as well. So it was a really nice example of a project internal into an organization and for a chatbot. Let's move on to the third dimension in intelligent automation, which is vision. And computer vision these days actually allows the computer to extract information from images, from videos, but also from digital documents. And probably a very well-known application is OCR, optical character recognition, already popular since a few years, where you could provide digital documents to the OCR and it would be able to actually extract those words or sentences out of the document. Now, a few years ago, those documents still needed to be quite structured with a clear layout, and where you in advance had to say, okay, you have to extract this field from roughly this location on the digital document, and that field from another location at the bottom, and so on and so on. That has actually evolved, and by combining OCR with the natural language processing technology, we actually came up with intelligent character recognition, which is, well, actually doing the same thing, extracting information from digital documents, but they didn't have to be in a predefined format. By understanding what has been written through the NLP component, we could actually extract the information we wanted without predefining where to find it. And I'll come to an example in the next slide. But the same thing applies. The computer vision technology could also be applied with analyzing images or videos. For instance, with video analysis, the parking facilitator I was talking to in a previous example with the invoices also had the right to give fines to people that were wrongly parked in a certain country in Europe. When they did that, they had to take pictures of the infringement. But they would also, it would also be sometimes the case that there was a person on that picture that didn't need to be there, or another car that was not doing an infringement. So they really liked to get the people that were on the video, or the number plates of other cars that were on the video, blurred. And that's actually also an application of computer vision to detect faces and number plates and to blur them automatically, for instance, we did for that client. But let's have a look at the example of ICR. So this was an example actually which probably most of you know. If you're using an expense app, you probably have the ability to scan your expense, and the app automatically starts to detect what restaurant you were eating at, what the total amount was, and it puts that automatically in your expense app. So that's an application of ICR, where you're reading a picture, actually an image, and trying to make sense of where is the total amount, where is the restaurant name, and so on. And this is an example that probably a lot of you know. Another example that this is of course something we didn't do at a client, to be clear, but something we did do was around automated document classification. And it's really about classifying, labeling, and archiving documents in an automated way. So what was the situation at this client? So the client was actually a real estate company that was managing a lot of buildings in actually the whole of Europe. Now, of course, that means that a lot of inspections needed to happen in those buildings, and they needed to get all the reports of the inspections. So they were getting that on a daily basis, and it was about 400,000 reports per year that they were receiving, or certificates, or whatever. And they were receiving them in 7 languages. So you can understand this is a huge amount of documents that they are receiving, and they needed to classify and store that all in their document management system. So what was the case there? There were actually 2.3 FTEs busy with working and on these documents and classifying them into their document management system. Now that was not all, because they were not all the time sure that the classification was right. So there was also a good part of those documents that were sent to the business to actually see and validate if the classification and labeling of those documents was done in a proper way. And that roughly was about another almost full FTE that was busy with that from the business side. So there was more than 3 full-time people busy with just classifying and archiving documents. So what did we do? Actually, we built a robot that could actually take those documents and classify them in an automatic way. So it would read documents, get the necessary labels and information out of that, understand to which property it's related to it, and classify that under the right property with the right information in the document management system. And only a small subset of documents where there was not full 100% certainty of the right classification were sent to the people supporting that, and so they had much less manual work to do and just treat the exceptions. So this created a huge value for that company. So, okay, so that was our example of vision, and then maybe let's go to the last dimension. That's the thinking and learning dimension. And then machine learning here is of course the most evident one that you think about. Now, this is also the dimension that is the least evolved, I would say. There's been a lot of progress the last years in NLP and computer vision, and it's been more and more industrialized and applied in quite some companies. Machine learning is still a few steps behind, I would say. There are big advances in that technology, but it's not as mature as the other ones, right? But the idea in machine learning is that you feed actually past situations to the machine learning algorithm, and based on that it can compare it with a current new situation and see where it matches the most with, and then define or calculate the probability of a certain outcome of that new situation. That's actually the goal. So I know you may know that a lot of insurance and banking organizations use it these days, for instance, to calculate your insurance policy and risk that you're running. Okay, so that were actually the 4 dimensions of intelligent automation, explained with a few examples. I hope that gave you some more insights on the possibilities of intelligent automation and what it can mean for your company. Should you have questions or anything, feel free to reach out, I would say. And I really hope you enjoyed the 2nd episode, and stay tuned for another one. See you around. Bye-bye.